Hello class, this is just a example of differentiation by first principles. Here's the portion of what we were talking about, how we just do the mathematics. At this point you can just follow the steps and give it a go yourself. Here we go. So here's the formatting that I go about doing. So I'll leave this as close as we can. So for this function, we need f of x plus h. So let's find that one first. F of x plus h. And we're going to get this prepared. So 2 bracket squared, because inside this bracket is x. For this, we're going to substitute x plus h into here and expand this expression. This becomes, for this, it becomes square the first plus square the last plus 2 times the product. So 2 times x times h, 2xh. Let's expand this one again. It becomes 2x squared plus 4xh plus 2h squared. So this here is f of x plus h. You could rewrite this, but we already have f of x. F of x is the question itself. So now to find the derivative, we say f prime of x is equal to the limits as h approaches 0 of f of x plus h. That's this expression here. Lucky for me, I can just copy it like so. So that's f of x plus h. And from this, I'm going to subtract minus f of x. So that's 2x squared. This is all over h. Let's move this, make some more space for myself. Let's collect like terms. This is 2x squared and 2x squared. One of them's a minus, so we can cancel these two. This leaves us with, this is just for the sake of time. Normally I'd rewrite this, but I'd like to keep this video as short as possible. So we have limit of 4xh plus 2h squared all over h. Once again, we need to keep factoring this. Let's normally again, I would write this out again, but for the sake of time, I'm just copying it. So now we're going to factorize h out. So h on the outside, 4x plus 2h all over h. Once again, I need some more space. H's cancel, leaving us with the limit as h approaches 0 of 4x plus 2h. Now to apply the limit, we simply substitute h is equal to 0. So, well, if h is 0, that's 2 times 0, that goes away, leaving us with 4x. So to finalize this question, we can say that f prime of x is equal to 4x. So the derivative of this function is 4x. Let's do another example. Let's bring this back up so we can see what we need. So for this, we need f of x plus h. So let's find this one first. F of x plus h. we're going to substitute x plus h into x squared. So this becomes x plus h squared. That's this one done. Plus, substituting it again here. That's 2 bracket x plus h. Expanding this first one becomes x squared plus 2x h plus h squared plus 2x plus 2h. Here's where it's going to get slightly messy. So now the derivative f prime of x is equal to the limit as h approaches 0, simply just following this, of f of x plus h. Well, we've just calculated that. This is f of x plus h. So let's duplicate this. We need that. And all of this, we're going to minus f of x. So bracket, f of x is this expression. That's x squared plus 2x. And this is all over h. Let's move this out of the way now. The rest is just going to be algebra. Copying this limit as h approaches 0. Here's where it gets a little tricky. We have x squared minus x squared, so those two will cancel. We also have 2x minus 2x, so that also cancels. So this all cancel. We are left with 2xh plus h squared minus, plus 2h all over h. Factorizing h from this, becomes h on the outside. This becomes 2x plus h plus 2 all over h. Cancelling the h's, we're just left with limits as h approaches 0 of 2x plus, I'm just going to rearrange this, plus 2 plus h. And now lastly, we're going to apply the limit by substituting h equals 0. Well, if we do that, this becomes 0, so that really just goes away. And we're left with 2x plus 2. So the derivative, f prime of x, is 2x plus 2. To clarify, the derivative of this particular function is 2x plus 2. I hope that gave you an insight into it. I'm just going to do one last example. You don't have to watch it all the way through, but yeah, you can move on to the exercises from this point. Here we go. Once again, we need f of x plus h. So f of x plus h becomes negative 3 bracket, substituting x plus h into here, and substituting it as well into here. So this becomes 2x plus h. Expanding these, we are left with negative 3, square the first, square the last. Sorry, I'm just expanding this one here. Expanding this one as well. And one last expansion of this bracket. So negative 3 times x squared negative 3 times 2xh, that's negative 6xh minus 3h squared plus 2x plus 2h. Following this formula here, so f prime of x is equal to the limits as h approaches 0 of this entire expression, that's x plus h, minus this expression here. So let's copy that, insert it there, make it blue, and so that's the top. So this is f of x plus h, this is f of x plus h, minus, let's use a different color, nope, minus f of x. All of this is over h. Copying this. Okay, let's do some expanding and cancelling here. Negative 3x minus 3x, that's plus 3x squared, so negative 3x squared plus 3x squared. These two will cancel. We have here positive 2x minus 2x, so these two also cancel. This leaves us with negative 6xh minus 3h squared plus 2h all over h. And hope you can see now that it's just going to be a factorization of h on the outside, so h outside of negative 6x minus 3h plus 2 all over h, cancelling these two out, leaving us with negative 6x plus 2 minus 3h, and now applying the limit by letting h equal 0, so 3 times 0, that goes away, leaving us with negative 6x plus 2. So the derivative of this function is negative 6x plus 2. So hope that gave you an insight into using first principles to find the derivative. Hope to see you in the next video. Best of luck.